degree measure. How many degrees in a circle? 360. We have 0. We have 90. 180. 270. I know you already know this. We're just reviewing it. So, on the coordinate plane, we count the x-axis to the right as 0 or 360. That's where we start. And anytime we draw a degree or an angle, we start with the initial side of the angle, and we have what we call then the terminal side of the angle. Initial and terminal. Theta represents the degree measure. So if you're talking about 1 degree, you're talking about 1/360th of the circle. Now we talked about radians, but let me put it in a new way that really seems to make sense to people. Again, radians might be, say, the metric version of this, okay? And we like to use radians a lot. So, if this radius is r, then that length would be r as well. 1 radian is when the arc length is the same as the radius. See? When the radius is the same. Now that it's approximately about 60 degrees, it's like 57, something like that. Watch what happens if I put another one on it. And this will all make sense to you guys in a second. So if I put another radius on, and if I put one more on, so how many radians do I have there so far? 3. And 3 of them fit within 180. I've got a little sliver left over here, don't I? 0.14, right? How many radians fit in 180? Pi, yeah. How many would fit in 360? 2 pi. So I didn't draw it geometrically before, we just talked about it, but that's really what's happening, is that kind of those sectors of those arc lengths, 6.28 radii wrap around the circumference. Does that kind of make sense? Click for you a little bit. So that's 1 radian, whereas 1 degree would be like, you know, really small, right? Okay, you got it. You don't care. All right, converting between degrees and radians. Here we go. All right, you remember that if you want to go from degrees to radians, you take theta and you multiply it by pi over 180. If you want to go from radians to degrees, you go theta and you times 180 over pi. That's our conversion. That's how we go back and forth. Need to know that. What was that? Okay. Let's try to quick construct all the values that we know. Let's do degrees first. This is 0. What's the next one that we always talked about? 30. Then 45, 60, 90, 120, 135, 150, 180, 210, 225, 240. Just keep saying numbers, so you know, odds are one will be right. 300, 315, 330, 360. Got it? Remember that? So you should be able to think of that in your brain. Remember, we can construct 30, 60, 90 or 45, 45, 90 triangles to be able to figure out the exact position of all the terminal points where it crosses through the unit circle, you know, what x, y values we have and everything else. But what we're trying to do right now is, again, just connect that frame of reference between degrees and radians. So 30 degrees. What is it in radians? Pi over 6. Again, this is just review. 45. Pi over 4. Pi over 3. Pi over 2. And if you can remember those are really like the building blocks, aren't they? From there, you can construct all the others. So 120 would be 2 pi over 3. 135. 3 pi over 4. 2 pi over 4 would be 90. 3 pi over 4 would be 135. 150. 5 pi over 6. And every single one hereafter is exactly 180 degrees opposite from another angle, right? And so all you need to do is just add on pi to the previous value. So 0 plus pi is pi. Pi over 6 plus pi, or 6 pi over 6 plus pi over 6 is how many pi's over 6? 7 pi's over 6. Pi over 4 plus 4 pi over 4 is 5 pi over 4. Pi over 3 plus 3 pi over 3 is 4 pi over 3. Pi over 2 plus 2 pi over 2, 3 pi over 2. Two pi over 3 plus 3 pi over 3, 5 pi over 3. 3 pi over 4 plus 4 pi over 4, 7 pi over 4. And 5 pi over 6 plus 6 pi over 6, 11 pi over 6, pi plus pi, 2 pi. You got them. Those are the basic ones. They locked up in your brain. You just took a quiz yesterday. Did you ace it? You know what the last one was? 19 pi over 12. Did you get that? Did you fully reduce it? Some people didn't. Okay. Rewrite each angle in radian measure as a multiple of pi. You guys know how to do this. We did them all. Let's try a little bit more difficult one. 105. It's not up there. What do I do? 105 times pi over 180. 105 and 180. What do I divide them both by? 5. 5 would be fine. So 21 pi over 36. (21 pi over 6). Both are divisible by 3. 7 pi over 12. So sometimes you just need to simplify that fraction. Okay? Any questions how I got that? All review, right? You're going to do so well on this test. Right? Skywalker, you're ready to redeem yourself, aren't you? He says, I am. I'm ready for another one. Did you do well on that quiz yesterday? Okay, I'll put that on the tests. You guys want that one on tests or under homework? Tests, because you probably did pretty well yesterday, right? Okay, we'll put it there. All right, so kind of change gears a little bit. You know how we can express radians in terms of pi, or we could write it out as a decimal. The same thing is true for degrees. Now, when you break degrees up into smaller bits, like right here, this is in decimal form, we can convert it to what we call degrees, minutes, seconds. So just like you break up time into minutes and seconds, we do that with degrees as well. Because sometimes, like 1 degree might seem really small, but the further you go out, the wider that gets, right? I mean, like right now, if I were able to like point my arms at 1 degree towards Larissa, I might I might get like right to her nose and that's it. But by the time I get to Danny, it might be between his ears, right? You know, I mean, 1 degree, it's going to get larger as time goes out. So we like to go smaller, minutes, then we like to break that down to seconds. 5 seconds is really small. Okay, it's a really small measure. Like over 500 feet, it would only be like 1/4 of an inch. So that's usually pretty good for stuff that we want to do within normal means here. Okay, outer space, totally different. Okay, so how do we convert? Well, how many minutes do you think that there are in 1 degree? 60. So we're going to multiply by 60. Take the decimal and multiply it by 60. So think about it. 80.6125. Is that more than half of a degree or less than half of a degree? More than half. So more than half of a degree would be more than 30 minutes, right? So when we multiply this, we'll get more than 30 minutes. Take your calculators and multiply 60 times 0.6125. Tell me what you get. Who's got the quickest hands? I bet it's Haley. Anyway, you got. So we've got 80.3675. Well, I'm sorry. So we got 80 degrees and 36.75 minutes. 0.75 minutes. That's 3/4 of a minute. 3/4 of a minute would be how many seconds? 45. And if you take 0.75 times 60, you're going to get 45. So we take the decimal, or 0.75 times 60 again, and you're going to get 80 degrees, 36 minutes, and then 45 seconds. You know, just multiply by 60. How do you think you go the other way? Divide by 60. Yeah. So we'll take 52 and we'll divide it by 60. So we'll have 36 degrees and 12 point something. We got to come up with a decimal. What's 52 over 60? Okay, so 0.867 minutes. Now we want to bring that all the way back to a decimal. So we're going to have 36.12 minutes. Is that more than half of a degree or less than half of a degree? Less than half. What's that, Danny? So we're going to take 12.867 and we're going to divide that by 60. What's 12.867 divided by 60? 21445. So we have 36.21445 degrees. So we're able to convert back and forth. What do you think? Why don't you try one on your own, okay? Try example 2. Convert the following degree measurements to their other form. So this one's currently in decimal form. You're going to go forward into degrees, minutes, seconds. And this one is currently in degrees, minutes, seconds. You're going to go back into degrees decimal, okay? Just like above. Why don't you give that a shot, and I'll hand out your stuff that you guys are getting right now. Okay. All right, let's pick up here then. Sketch each angle in standard position, 42 degrees. If you get a problem that says that in your homework, just draw that. Make sure that you draw the initial side of the angle. Put the terminal side in the correct quadrant. 42 degrees will put us in which quadrant? The first quadrant. And it's nice to show a little arc there with an arrow to show which way you turned. And we would just say that's 42 degrees. And that's all you need to do for a problem like that. That's it. That's it. So you should know if you're working in degrees or radians. The second one, B, am I in degrees or radians? Degrees, because it says degrees. So negative 113. Which quadrant will that put us in? The third, because we're going negative in the opposite direction. So I put my initial side down, and then I rotate in the opposite direction, 113 degrees. Any questions how I did that? 4 pi over 3 degrees or radians. Radians, is that more than a pi or less than a pi? It's more than 1 pi. Which quadrant does that put us in? It puts us in the third quadrant as well. Sketch your little graph. Put your initial side down. Go all the way over the other side. We'll call it good. 4 pi over 3. Negative 4.6 degrees or radians? Why? There's no degree symbol. 4.6 is simply the numerical expression. It's not in terms of pi. So we can do this. But this is going to require some smarts on our part. So put your thinking caps on. Let's see here. I'm going negative. We're going to start with 0. If I go negative, this is going to be negative 1.57, right? Because negative pi over 2. Negative 3.14, negative 4.71, and negative 6.28. So which quadrant will that put me in? The second quadrant. Very good. I've been trying to get Mallory to laugh all hour and I haven't been able to yet. Am I not funny today, Mallory? You're not funny, you're just funny looking. All right, 420. Here we go. What's different about that one? More than 360, so I have to show as I draw the angle that I go around more than once. So that's my initial side, and I go around how much further than once? 60 degrees more. Good job. That's that. Got the idea? What? What'd you do? Tyler. It's okay. Yeah, now we know what it's like to not be part of the joke. It's all right. Outside looking in. All right. Another example, nice and easy. Find the angle in radians that satisfies the condition below. So if we have a radius of 7 and an arc length of 3, okay? So I'm going to draw this. So I have a radius of 7. And an arc length of 3. Now you just got to think about this real intently for a while. True or false? That is more than 1 radian. A radian is when I have 1 full radius stretched on the arc. Do I have a full radius here? No. Do I have even half of a radius? No. Guess how much of a radius I have? 3/7 of a radius. I will show you. Are you ready? Watch. I'm going to show you a cool formula for arc length that can help you convert back and forth between this stuff. You guys learned the other day that S, or arc length, was equal to, we took 2 pi r, which was the circumference, and we multiplied it by theta over 360. We started doing that when we were working with degrees and radians. Now, I'm going to give you an easier formula. That's kind of bulky, isn't it? Let's switch it. Okay, I'm going to rewrite something. S equals Watch how this goes. I've got, let's see, what should I do here? Oh, yes. 2 pi r theta over 2 times 180. Everybody see what I did there? I just put the 2 pi r on top, and I rewrote 360 as 2 times 180 instead of 360. Everybody okay? What happens to the 2's? Cancel. Now, hold on. If I take, watch, if I take theta and I multiply it by pi over 180, what does it convert it to? Converts it to radians. Remember, if we take a degree measure and multiply it by pi over 180, it turns it into radians. So this will go away. I'll be left with S equals r theta, where theta is in radians. So all of a sudden, arc length is simply the radius times theta. See how easy that is? So now look at this problem up here. Radius of 7, so S equals r theta. S equals 7. Well, I'm sorry. Arc length is 3. Arc length. 3 equals, r is what? 7 times theta. How do I solve for theta? 3 over 7 equals theta. That's my angle measure. Isn't that nice? It's a very simple formula. How about radius of 4 and arc length of 13? S equals r theta. So we have S is 13, r is 4, theta. How do I solve for theta? 5 by 4. 13 fourths is equal to theta. Cool. Like that? We're going to derive a lot of formulas in trigonometry. That's part of the fun. Yeah, we're going to do area of a sector now. Sector, a lot of times they refer to as the letter K, or maybe even A. You could do either or. K is probably more common. So the way that we figure out an area of a sector is we take the area of a circle. What's the area of a circle? Pi r squared, and we multiply that by theta over 360. What do you think I'm going to do now? Yep. So that's same thing as pi r squared theta over 2 times 180. Now, pi over 180 times theta converts it to what? To radians. So what I have now is, looks like I have a half left, times r squared times theta, where theta is in radians. Wasn't that a nice formula? It's a lot better than the first one, isn't it? What? Theta represents the angle measure in degrees. Yeah. Theta is the angle measure. It can be degrees or radians. When you write it like this, theta over 360, 360 is referring to degrees. That's what you always learned when you're in geometry. Don't you remember all your geometry? Oh, yeah, no, you maybe didn't use theta then. You're going to use theta now all the time. Theta is 100% all the time. We're going to do that. It's going to be angle. You're going to use it every day in here. So, yep. Learn to love it. The Greeks were amazing. Right, Andrew? The Greeks were the best. Andrew agrees. Must be right. Okay. Find the length of an arc on a circle. So we're just going to do these two examples. That's it. Okay. Then we're going to stop for the day. These are easy. Find the length of an arc on a circle of radius 24 that subtends a central angle of 60 degrees. So what does that mean? That means I have a circle, and there's an arc on that circle that subtends. What that means is it intercepts, or it wraps around, an angle of 60 degrees. The radius is 24, And what I want to do is I want to find S. S being that arc length. This is find the length of the arc. Okay, what's our formula for arc length? Yep, S equals R theta. But theta has to be in radians. I'm currently in degrees. What's 60 degrees in radians? Pi over 3. Great. Now you know why you had your quiz. So you can do that as opposed to just try to figure it out all the time, right? Now you know. Now you're glad you did it. So, wow, Mr. Gens, you knew what we needed to be able to be successful. All right, here we go. S equals, what's my radius? 24 times pi over 3. What's 24 times pi over 3? 8 pi. So 8 pi is the length of your arc. Simple little formula. That's the answer. Cool. Area of a sector. Well, sector area, that's different. The formula there is K equals, or A, whatever you want to use, equals 1/2 times R squared times theta, where theta is in radians. Do we know our radius? Yes. Do we know our central angle in radians? Yeah, it's pi over 3 again. So K equals 1/2 times 12 squared is 144 times pi over 3. What's half of 144? 72. Well, 72 divided by 3? What's 75 divided by 3? 25. So 72 divided by 3 is 24. Done. Short assignment. Tomorrow we'll finish off just that little bit and you'll get a nice worksheet. 6.1, page 480. 1 through 3, 11 through 14, 41 through 47. Should go quick. They're pretty straightforward problems. And you guys are really bright, which is, you know, kind of the larger issue here. Well, most of you are pretty bright. Have a happy Valentine's Day. I'd like to give a shout out to my wife in case she watches the video tonight. I would just like you guys to know, no, she never watched my videos, and so I don't have to worry about this. You women drive me nuts. Okay? No, stop this. This is why. So, Kelly, what would you like for Valentine's Day? And she says, nothing, don't worry. She says, flowers just die anyways. I don't even know why people buy them. So I'm like, okay, I'm totally off the hook. Maybe I'll give her a card. Maybe I'll take her out to eat. But don't have to worry about flowers. Thank goodness. Yesterday, her friend drives by while I'm clearing ice off the driveway. And her friend says, hey, your son left this at our house when he was over. And by the way, I just talked to Kelly this morning. Did you know that she really wants flowers this year? Oh, you women! I swear! So last night, because I'm gone tonight, I had all this work to do last night. I had some bad stuff happen, but I go and I get the $15.88 Walmart special of a dozen roses, and I get a movie, and I get some flowers. I already got the flowers. I got candy. I've got a car. Got everything. Okay, got it all ready to go. Come home, get it all ready. She's sitting on the couch, say, "Happy Valentine's Day, honey. Come and see your present." And so she smiles as though she was extremely happy. And it's like, well, so then she said, I thought that we weren't exchanging gifts. And I said, honey, you know that there's an unwritten rule that is written by a woman that Valentine's Day, even if you're not exchanging gifts, all that means is the guy's not getting a gift. The guy is still on the hook. And you know what? She was very happy about it. She was very excited to have her gift. I was very glad to give it to her. And then she's like, well, what do you get a guy? What do you get a guy? Get a guy beef jerky. Buy me a pound of bacon. Buy me a pound of bacon and fry it up, for crying out loud. Give me a wrench and a movie that has a lot of shooting in it, and I'll be happy. We're not that complicated. Guys, raise your hand if you'd love a pound of bacon. We love it. We'll put it on our cereal. We'll put it on our finger and eat it. Jeez.